With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Question is, a chain is lying on a rough table with a fraction 1 upon n of its length hanging down from the edge of the table. If it is just on the point of sliding down from the table, then coefficient of friction between the table and the chain is. So here we can say, suppose this is our, let's say, table. Now here we can say, suppose this is our table and here we have this as our chain. Now suppose we can say this is our chain. Suppose this here is our chain. Now the question here says 1 upon n part of its total length. So total length is suppose L. So L upon n part hangs here downward. It says 1 by n of its length hanging down from the edge of the table. So the remaining length here will be our L minus L upon n. Question says the coefficient of friction between the table and the chain is being asked. So we can convert this question into pulley problem, 2-block problem here. So we can see here, this is suppose our, let's say, pulley system. Now here we can say, suppose there are 2 blocks here. So this is our first block, this is our second block hanging here downwards. Next we can say here, we have here, let's say, a string. So this is suppose our string which is attached to the block and to this pulley here. So we can say here the total mass of this chain is suppose m. So here 1 upon n part is hanging downward, which implies that m upon n part will be mass hanging downward, and here the remaining mass, let's say m minus m upon n, will be on this, let's say, table. So we can, let's say, here force balance this. So we have here the weight downward, that is mg upon n, and tension upwards. So we can say here the downward weight here will be equal to mg upon n and tension in upward direction. Next here we can say this, let's say here tension will be balancing the limiting friction to prevent the sliding. So tension will be equal to friction, and we can say here the weight of this will be, let's say, balancing the normal reaction. So we can say here from this block equation we have here as m minus m by n, that is m into 1 minus 1 upon n, let's say g, will be equal to normal reaction. So therefore we have here tension as equal to friction. So this comes as T is equal to, we have here F given to be as mu into N. Now we can say here from this block equation we have here as T is equal to our mg upon N. So here from these two tensions we can simplify here as our mu into N, as we can say as our mg divided by, we have here as N. Now normal reaction here we can see is given to be our, let's say, mg into, we have here as 1 minus 1 upon n, which is equal to our mg divided by, we have here as n. Now mg and mg cancels out, so this simplifies as mu into n minus 1 upon n will, let's say, cancel this n and n. So this will be equal to 1. Hence value of mu, coefficient of friction, will come out here as n minus 1. So here mu value is equal to our 1 upon n minus 1, which here we can see our option number 2 is the correct answer. Hence we can say 2 is our answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.